Hello. In this module, we'll continue talking about the binomial probability distribution. We'll specifically talk about the second method to calculate the binomial probabilities. The second method to calculate the binomial probabilities is using the table of probabilities. Usually these tables are available where right now in the given table, on the column side, it shows the P, which is the probability of success for an event of interest. N denotes the number of times the Bernoulli trials will be repeated. And X denotes the number of successes one can achieve in N trials. So you will notice that when N equals to 2, X can go from 0 to 2. And with P equals to 0.01, it gives all the probabilities of the occurrence of these events. Similarly, for 3, it goes from 0 to 3, and for 4, it could be 0 to 4, and for 5, it could be 0 to 5, and it goes on and on. So all these numbers within this grid are the various probabilities at different values of the probability of success. So we will be using this table to find out the probabilities. Using the example we talked earlier when we were seeking 4 successes out of 5, and we constructed the whole probability distribution. Let's look at the probabilities of this table. When n is equals to 5 and x can possibly take values 0, 1, 2, 3, 4, and 5, our probabilities with P 0.60 are given right here. When we calculated it using the formula of the probability mass function, probability of x is equals to 0 turned out to be 0.0102. And calculating it using the table, you will notice that when n is 5, x is 0, the value at P 0.60, the probability is 0.010. Similarly, for x is equals to 1, x is equals to 2, 3, 4, and 5, we have obtained these different probabilities. And you will notice that these probabilities obtained using the formula and the table are the same. So we can use either table or probability mass function to find out the probabilities for certain experiments. We can also use the cumulative probability function of the binomial probability distribution, which is also known as the distribution function. This distribution function is denoted by capital Bx and P, where n and P are the 2 parameters of the binomial probability distribution, where x denotes the possible number of successes from the trial. So capital B notation is used to describe distribution function or a cumulative probability distribution. You will notice another notation with small b, where small b within the brackets, it's k, n, and p. N and p are the parameters of the binomial distribution. Small b refers to the probability mass function. So probability distribution function of the binomial probability distribution can be given as sum k goes from 0 to n and the expression for the probability mass function. So what probability distribution function does is that it accumulates all the probabilities from the point x and previous. So if we have to find out the probability of x is equals to 2, let's say, then we will subtract the cumulative probability of x is equals to 2 from the cumulative probability of x is equals to 1. And it goes on. Let's try to do it using a table. This given table is the cumulative probability distribution for the binomial probability distribution. Over here, with n is equals to 1 and c, the number of possible successes that can occur within a trial, and the probability p, which is success for that specific event, are given on the column. So this shows that as we increase the number of x up till the value that is equivalent to the number of trials, that is n, the last probability will always turn out to be 1, which adds up all the previous probabilities. And it goes on for all different values of p, n, and c or k. So in our example, when n is equals to 5, p is equals to 0.60, and 1 minus p, which is q, is equals to 0.40. If we want to find out the probability of 4 successes, it could be written as b, which is small b, 4, 5, and 0.60. Here 5 denotes the number of possible outcomes, and 0.60 denotes probability of success. So to find out this probability, we will take cumulative probability from 5 and then the cumulative probability for 4 successes, and we subtract these probabilities, which is 1 minus 0.922, and it will give us the same probability, 0.078, which we could have obtained using the probability mass function or the table for the probability mass function. So cumulative distribution function works a bit differently as compared to the probability mass function, because in cumulative function, it adds up all the previous probabilities. And if we want to find out the probability at a point, we subtract all the previous probabilities from the probability that includes the probability at that desired point. There are certain mean, variance, and standard deviations of the binomial probability distribution. The mean of the binomial distribution is NP. Variance is NPQ, and the standard deviation is the square root of the variance, which is under root NPQ. For our example, the mean turned out to be 3, the variance turned out to be 1.2, and the standard deviation turned out to be 1.90. It is especially important to interpret the result. The range rule of thumb suggests that values are unusual if they are outside of these limits, when the maximum usual value will be mu plus 2 sigma, where mu represents the mean of the distribution and sigma represents the standard deviation of the distribution. Similarly, the minimum usual value will be mu minus 2 sigma. If any value goes beyond these two limits, we will consider those values as unusual values. So there is some specific effect of n and p on the shape of the distribution. For small p and small n, the binomial distribution will be right skewed. For large p and small n, the binomial distribution will be left skewed. But if the p is 0.5, then whatever the n value will be, either it will be large or small, the binomial distribution will always be symmetric. Whereas for small p but large n, the binomial distribution approaches symmetry. So these 4 conditions describes all the 4 points discussed earlier. That when p is 0.1, it shows a positive skew. 0.3, it shows kind of symmetry, but still a positive skew. 0.5, it is symmetric, and 0.8, it is negative skewed. So the third method is using the technology, where we will be using Microsoft Excel to find out the probability distribution. A special function that used to find out the probabilities for the binomial probability distribution is known as the binom dist, where it requires some information that could be x, n, p, and cumulative. We'll talk about it further later. Thank you.